Lesson 1.9 is about patterns, equations, and graphs. And by the end, you should be able to identify solutions of a two-variable equation using tables, graphs, and equations, much like yesterday in 1.8. Starting with vocab, solution of an equation with two variables would be an ordered pair that makes an equation true. So this time it has two variables. So I'm going to have an x and a y, which is why an ordered pair is what we need to make sure if this is true. Example, they will say, is 310 a solution of the equation y equals 4x? Well, because an ordered pair is x, comma, y, wherever I see an x, I'm going to put a 3, and wherever I see a y, I'm going to put a 10. So this one will say 10 is equal to 4 times 3. Well, because 10 is not equal to 12, we know that 310 is not a solution. Okay, which ordered pair or pairs are a solution to the equation y equals 4x? Sometimes there are more than one option, so you're going to have to try more than one thing. If this is my x and my y's, I'll label those first so I don't make a mistake. Then I'm going to start plugging them in. So 20 is equal to 4 times 5. Yes, that one is. Negative 20 is equal to 4 times negative 5. True. Negative 5 is equal to 4 times negative 20. Definitely not. And 6 is equal to 4 times 1.5. Also true. So this one had 3 possible solutions. Inductive reasoning, your third vocab word, means using patterns to reach a conclusion. Okay, for example, this table shows the relationship between the number of kites in an arrangement and the total number of ribbons on the kite's tail. Describe the pattern in the table and how many kites could you make with 275 ribbons. Okay, so 1 kite, 5 ribbons, 2 kites, 10 ribbons, 3 kites, 15 ribbons, 4 kites, 20 ribbons. Okay, so if we notice, we are doing kites, which could be like our x's. And we are doing ribbons, which could be like our y's. One, two, three, 4 they gave us, and we're looking for x. Ribbons, we know it's 5, 10, 15, 20, and we need 275. So what is my pattern? How do I get from here to here? Here to here. Looks like I'm multiplying. Correct? Multiplying by 5. 3 times 5 gives me 15. 4 times 5 gives me 20. So I'm going to have to multiply this times 5 to get me this. So what times 5 is equal to 275? X would have to be 55 kites. All right, in problem 3, they want you to extend the pattern that they've already started. This picture and the table on the next slide shows the relationship between the number of blue tiles and the total number of tiles in each figure. Extend the pattern and then figure out what is the total number of tiles in a figure with 8 blue tiles. Okay, so if you notice, we have 1 blue, but a total of 9 tiles. 2 blues, total of 18 tiles. 3 blues, with a total of 27 tiles. Okay, let's look at the table that they started for us. Here's those first 3 that they showed us. If we follow that pattern, we could continue, and it appears that we're adding 9 each time. So on the 4th box, or the 4th blue tile, the 4th figure, we would add another 9 and get us 36 tiles. The fifth one would get us to 45. And we're looking for 8, so we're going to add on a 6, a 7, and an 8. If I keep adding 9, 45 plus 9 gives me 54 for 6 blue tiles. I add another 9 and I get 63. I add another 9 and I get 72 total tiles if I have 8 blue tiles. Okay, extending the table or the pattern is just one way that we could solve this. We could also write an equation. If you noticed, I was adding 9 each time, but that doesn't help me if I start with x. We need to know how does x relate to y and make sure that it works every time. So if I start with 1, the possible ways of getting to 9 are by either adding 8 or multiplying by 2. Whichever we choose, it has to work for every step. So if I did 1 plus 8, that works. But 2 plus 8 does not get me to 18. So we know that it's not adding 8. Let's try our multiply by 9. 1 times 9 equals 9. 2 times 9 equals 18. 3 times 9 equals 27. So if we know that our pattern is taking the x value and multiplying it by 9 to give us our y value, that would be our equation. Okay, the last thing that you could do is you could actually graph your data and then follow the pattern on your graph. So 1 blue tile would give me 9 total tiles. 2 would give me 18. 3 is 27. 4 was 36, 5 was 45, 6 was 54, 7 was 63, and 8 was 72. 3 different methods. You don't have to use them all unless the book asks you to, but there's 3 possibilities. Okay, problem 3. This table shows the relationship between the number of chairs and the total number of legs. Okay, so x is our number of chairs, y is our number of legs. Extend the pattern and find the total number of legs on 10 chairs. Okay, so if I extend this, 1 chair has 4 legs, which means 2 has 8, 3 has 12, and I can keep going. So it looks like we are adding 4 every time. So if I extend it to 10, we need 6, 7, 8, 9, and 10. By adding 4, I'm going to have 24 legs for 6 chairs. For 7 chairs, we would have to add another 4, and we'd have 28. For 8 chairs, we'd have 32. For 9 chairs, 36. And 10 chairs, we would have 40 legs. Okay, now sometimes for some people it's easier to graph things before writing the equation, or some people can just see the equation. If you were going to graph next, our x values or our number of chairs would go on the bottom, and our y values or number of legs would go on the y-axis. So we would go over 1, up 4, over 2, up 8, over 3, up 12, and so on. And I actually run out of space in here, so I may have to count by something other than just ones on my table, or my graph, I'm sorry. The equation we noticed was for every 1 chair, we have 4 legs. So the number of chairs multiplied by 4 legs should give us the number of legs total. Let's see if that works. If I take my x value and I multiply by 4, I get 4. If I take this x value and multiply by 4, I get my y value. It appears to work every time, which means that is my equation. Both Carrie and her sister Kim were born on October 25th, but Kim was born 2 years before Carrie. How can you represent the relationship between Carrie's age and Kim's age in different ways? All right, so we should maybe writing an equation in this case would be helpful. So I'm going to call Kim my y values and Carrie my x values. And because of this first sentence, Kim was born 2 years before Carrie, I know that Carrie plus 2 years is going to equal Kim. So that's my equation. That may help with my table. I'm only going to do the first 5-ish numbers. So when Carrie was born, she was 0. Her sister Kim was already 2. When she turned 1, her sister was 3. When she turned 2, her sister was 4. When she turned 3, 5, and 4, 6. Okay, you would also be able to graph this. So down on your x-axis would be Carrie. On your y-axis would be Kim. And then I would graph over 0, up 2, over 1, up 3, and this one would be a pretty steady line. Will runs 6 laps before Megan joins him at the track. They then run together at the same pace. How can you represent the relationship between the number of laps that Will runs and the number of laps that Megan runs in different ways? Okay, so we know no matter what that Will is always going to be 6 laps ahead of Megan. Okay, so Will is going to be our y, Megan is going to be our x. So Will always equal Megan's laps plus 6. If I start a table, Megan is our x, so when she has run 0 laps, Will has run 6. When she's run 1, because now once she joins, they're running at the same pace, so then he has run 7. Once she's run 2, he's run 8, 3, 9, and so on and so forth. You are 4 inches taller than your brother. How can you represent that relationship between your height and your brother's height in 2 different ways? Okay, you decide if you're going to make a table, equation, or graph, but choose 2. I chose to make a table and an equation. I called myself y's so that I could have my height equaling 4 inches plus my brother's. Okay. Then in my table, when my brother was, I don't know, we'll give him 60 inches, then I would be 64. If he was 62 inches, I would be 66. If he were 65 inches, I would be 69. And that you could choose any numbers that you wanted. Okay, so hopefully now you're able to create and extend a table, write an equation, and then use that to make a graph. If you have questions, make sure that you come ask me. Otherwise, here is your